Hey, it's Mr. Estrada here, and there is our learning target for today's video. In this video, we're going to deal with the measures of line segments in parallelograms. Our last video, we focused on the angles of parallelograms, so now the focus is on the measures of line segments. So let's review a little bit. Parallelogram is basically a quadrilateral with both pairs of opposite sides parallel. This video, though, we're going to focus on property 1 and property 5. Property 1 and property 5 deal with the measures of line segments, while properties 2, 3, and 4 deal with the measures of angles. So that's very important, and that's something that maybe you should write down. Here, I'll write it down myself. All right, so there it is. Properties 1 and 5 help with finding segments, while properties 2, 3, and 4 help with finding angles. And yes, even property 2 helps with finding angles because property 2 helps with finding alternate interior angles and same side interior angles. Okay, I digress. Moving on. So today we're only dealing with property 1 and property 5 because those are the ones that deal with segments. Here is example 1. We are asked to solve for x, and we know we're dealing with a parallelogram here because the opposite sides are parallel. And again, sorry to be so repetitive, but we are also dealing with segments here, not angles. And in a parallelogram, the opposite sides are equal. So we could say FG is congruent to EM. And then we get 7x minus 1 equals 6x plus 2. So x is equal to 3. So that's one way to solve for x, right? We know that FG is congruent to EM, so we could set these two equal to each other. Or another way you could solve for x is you could say segment FE is congruent to GM, and you would get 10 equals 2x plus 4, and you'd get the same thing, x equals 3. All right, not bad. Our next example, example 2, the figure below is a parallelogram, solve for x and y. So you know from the properties that in a parallelogram, the diagonals bisect each other. Now let's review. The word bisect means that they intersect at their midpoints. The midpoint of a line segment divides the line segment into two equal segments. So if you're given that M is the midpoint of AB, then you could say AM is congruent to MB. Let's apply that to our example 2. Since the diagonals bisect each other, so, you know, the diagonals are DB and AC. Since they bisect each other, H is the midpoint of AC and BD. So if H is the midpoint of AC, we could say AH is congruent to HC. And H is the midpoint of BD as well, so we could say DH is congruent to HB. Just a little side note here, you notice that I use 2 tick marks to distinguish, to basically make it obvious that only DH is congruent to HB. And I used 1 tick mark for AH congruent to HC. Because if I use the same amount of tick marks for all the line segments, it'll look like everything is equal, and that would be incorrect. Okay, back to the problem. So if you want to solve for x, we know that DH is congruent to HB. So we get 2x minus 5 equals x plus 7, and we get x equals 12. And if you substitute it back in, you'll get 19 for DH, and you'll get 19 for HB, which makes sense because they are supposed to be equal to each other since H is the midpoint. Let's solve for y. To solve for y, we know that AH is congruent to HC, so we could write 6x plus 1 equals 4y plus 9. We would get y equals 4. When you substitute it back in, you'd get 25 for AH and 25 for HC, which again makes sense. They should be equal to each other because H is the midpoint of AH and HC. Alrighty, let's try one more. Example 3. The figure below is a parallelogram. Solve for x. And f equals 8, and it says df equals 6x minus 2. So what it's saying is the whole diagonal, so this whole thing, df, is equal to 16 units. So df, all of this diagonal, is 16 units. And we know nf is 8. Now, why did I say df is 16? Where did the 16 come from? Right? Did it just come out of nowhere? No, it didn't just come out of nowhere. I know that the whole thing df is 16 because dn is also 8, because n is the midpoint, right? So again, in a parallelogram, the diagonals bisect each other, so n is the midpoint of df. They want us to solve for x. I know the whole thing is 16. So if I want to solve for x, the whole thing is also expressed as 6x minus 2. So I could say 6x minus 2 equals 16. And I would get x equals 3. So there is another way to approach the problem. So you can also approach it like this. So let me get rid of that. So you could label NF8, and we know that DF is 6x minus 2. So the whole thing is 6x minus 2. So what do we know? Well, we know that DF is equal to 2NF. So we can write 6x minus 2 equals 2 times 8. And that would give you the same thing as x equals 3. Alright, so I hope this video helps. Take care.